73 is a two-dimensional collision problem, and even though it doesn't say, uh, well, I mean, it's not even though, because it doesn't say that it's elastic or inelastic, then it's probably best to not assume that it's elastic, even though you might want to. So, luckily, we don't need a conservation of kinetic energy equation to solve this, and so we're just going to go straight ahead with a conservation of momentum in the x direction and a conservation of momentum in the y direction. So you got a particle where we'll call it mass 1, and it's 4 atomic mass units or atomic units, atomic mass units, we'll just call it 4. Goes in and then bounces down that way. And then another particle starts here, we'll call it M2, and it bounces up that way. So this is M2, and that is 16 atomic mass units, and it is bounced up with a speed velocity to final of 1.2 e to the 5 meters per second. And the angles that these both deflect at, this one goes down 64 degrees, and this one goes up 51 degrees. Alright, so let's do momentum x first. Conservation of momentum in the x direction. So that's m1, hold on a second, times v1 initial plus m2 v2 initial, and that equals m1 v1 final. That v1 final goes down that way, right? So we just want the x component, which is going to be adjacent to this angle, so it's cosine 64 plus m2 v2 final cosine 51. We can plug some more things in. We know it's at rest initially, and m1 is 4, we're saying, so 4 times v1 initial equals 4 times v1 final cosine 64, whoops, plus 16, and jeez, no, hold on. All right, so where was I? Oh, yeah, 16, and v2 final is given right here, 1.2 e to the 5 times cosine 51. And that's sort of as far as we can go right now. Oh well, no, we can cancel 4, 4. That turns into 4. These cancel. Alright, that's about as far as we can go. Let's do the y direction. This is not moving in the y direction initially, and this is at rest. So I'm just going to take a shortcut and say 0 plus 0 equals m1 v1 final sine 64 plus m2 v2 final sine 51, 0 equals 4 v1 final sine 64 plus 16 times 1.2 e to the 5 times sine 51. 4's cancel like that. So we get v1 final is rearrange this algebraically. I'm going to skip all those steps. You guys can do that. So that's blah blah, and you get 41503.97 meters per second. Take that, stick it up. Whoops, I forgot one. Stick it up in there. Solve for v1. v1 equals, that's a number, times 6 cosine. Those are all numbers. You guys can do that algebra. And that's 4, 8, 4, 012.7 meters per second. So the initial velocity of m1 is this, and the final velocity is that. Looks like it slows down a little bit, which kind of makes sense because some of its momentum, its mass didn't change, but some of its momentum went into this one over here. Alright, and one more problem for this chapter. Bye bye.